The secret doodads of cyberspace. What the heck is a finite state machine? There is normal programming, or casting code spells like a normal wizard, and then there is world building. We are excellent navigators. This is very likely an evolutionary adaptation, and it may be responsible for our amazing intelligence. Our mechanisms used in navigation might have been kind of copied over to help us become really great apes. Memory palaces are a neat example of how great our minds are at navigating. And if you close your eyes, you can totally trace all the walls in your house in very great detail. Programmers use this ability to create very rich concepts, ones that you must hold in your memory, in your inner eye, to properly use. My favorite example are MUDs, or multi-user dungeons that can be programmed inside out, a perfect example of world building. I think they are going to make a comeback, and may even be used to enhance language models. Why the heck not? Sadly, the information superhighway is not quite real, nor are all the car analogies that programmers hate to make. But we should keep pretending that we don't know anything about the internet and force them to keep doing it. It's very funny. Hey, could you explain that with a car analogy? No doubt you might have heard of data streaming. And that too is an actual, real, and very neat example of imagination-backed cyberspace machinery or cyberspace engineering. Streams don't just stream binary data either. They can stream OOP objects with different properties, and they can be split, transformed, mapped, reduced into all kinds of interesting things. A state machine is a device that is less complicated than multi-user dungeons, but more creative than just streams. The reason why you would want to use one is to simplify your code. It's a huge reason. When you are using a finite state machine, you just have a finite and well-labeled number of states that your program can be in. Whatever isn't a state is an error to be trapped, or just doesn't really matter. The state is the main thing. That means you don't need if statements to probe what is going on like a caveman, or see if something can happen or is ready to happen, or if you can proceed to the next stage. If something failed to load, or is still loading, or your program is still starting even, you are in the loading state. You will absolutely stay there until loading or whatever completes and issues a proper state change. Here you will go to ready state or error state sometimes. As a result, you don't need to check if you are ready or had an error. If you are in the error state, you simply focus on displaying an error message or asking the user to retry. If you are in the error state, you 100% had an error. You just deal with it. If you are in the ready state, you don't need if statements to see if all your files have loaded and to check if maybe there was an error or if something is missing. Ready state means that you are ready, that you are peachy. There were no problems, no errors, everything has loaded. You don't need if statements to test anything. It is all there. The only way that the loading state will transition you to ready state is when everything is okie dokie and there were no problems. Everything has loaded. Finite state machines are a great power. Just imagine how much easier it is to read code when you don't have all these nested if statements. Finite state machines also enforce state transitions as a huge bonus. That means when you are in the loading state, you cannot possibly transition to play song or playing state, for example. That transition only makes sense from the ready state, because you need to load the song before you can play it. Well, there may be some bugs that you could catch this way. The big benefit of guarded state transitions, where each state has just a specific set of actions and nothing else, is the map that you are forced to create. A map of all the program states and what transitions each of the states can go into. Aside from eliminating a ton of if statements and all those edge cases, finite state machines reveal a complete map of all the program flows and where it all goes.